In June 1969, engineers shut down Niagara Falls. Not all of it. The Canadian Horseshoe Falls kept roaring. But on the American side, the water vanished, leaving a 100-foot wall of bare rock where a waterfall had been. They did it with a 600-foot cofferdam across the American Channel. More than 28,000 tons of rock redirected the water around Goat Island and toward Horseshoe Falls. The immediate reason was erosion. Engineers feared the American Falls was slowly breaking itself apart. But when they finally reached the exposed cliff, the most obvious repair, removing the mountain of fallen rock below it, looked as if it could make the problem worse. America had proved it could stop Niagara. Now the United States and Canada had to decide whether anyone should rebuild a natural wonder. That answer would take far longer than stopping the water. The problem had been growing for decades. Major rockfalls in 1931, 1954, and 1959 sent roughly 130,000 cubic yards of stone to the bottom. By the late 1960s, about 280,000 cubic yards of talus, the steep pile of broken rock, lay beneath the American Falls. To some visitors, that pile made the American Falls look shorter and weaker than the clean plunge of Horseshoe Falls across the river. To engineers, it raised a more serious question. Was the exposed cliff stable, or was another section preparing to fall? In 1965, Niagara Falls officials and the local newspaper began a campaign to save the American Falls. The argument soon moved beyond New York. Niagara marked an international boundary, and changing its flow required the cooperation of both the United States and Canada. The International Joint Commission created a board of American and Canadian experts. They could study photographs and survey the rim, but the most important evidence was hidden behind thousands of tons of falling water. To reach it, the water had to move. Goat Island already divided the Niagara River into two channels. Engineers did not need to dam the entire river. They needed to block the smaller American Channel and let the diverted flow continue over Horseshoe Falls. This was not a concrete wall built safely on dry ground. Trucks carried rock and earth directly toward the moving channel at the eastern end of Goat Island. Load after load extended a temporary barrier into the current. With every few feet, the remaining gap became narrower, faster, and harder to close. On June 12, 1969, the Cofferdam was completed. The roar on the American side weakened into scattered streams. Then the cliff stood almost dry. Horseshoe Falls still thundered nearby, but the familiar wall of water beside New York had become exposed stone. For the first time, engineers could walk through the riverbed above the brink and work directly on the face of the American Falls. If forgotten American history like this deserves to be uncovered, like the video and subscribe. The harder part was deciding what to do with Niagara once engineers could finally touch it. The dry falls became a laboratory. Crews drilled 48 core borings into the rock. They mapped fractures, photographed the cliff from precise positions, traced water through cracks, and installed instruments to measure pressure and movement. Even the absence of water created a new danger. The exposed Rochester shale could dry, crack, and crumble, so sprinklers kept parts of the cliff wet while the investigation continued. One Army Corps commander said the geologists were in a dream world. They had access to a landscape that was normally untouchable. The measurements revealed why Niagara could not be repaired like a concrete wall. At the top of the falls sits roughly 80 feet of hard Lockport dolomite. Beneath it is about 60 feet of softer Rochester shale. Water enters joints in the upper rock, reaches the weaker layer, and slowly removes support from below. Eventually, a section of the harder cap loses its foundation and falls. That process is not damage happening to Niagara. It is the process that created Niagara. Over thousands of years, erosion moved the falls roughly 7 miles upstream from the Niagara escarpment. The talus complicated the story. It was evidence of earlier collapses, but it also protected parts of the vertical face and slowed further erosion. Removing it could make the falls look taller while accelerating the same process the project was supposed to control. On November 25, after more than 5 months, crews removed the Cofferdam. Water pushed back into the American Channel, crossed the exposed riverbed, and reached the brink. The dry wall disappeared behind white water. The roar returned. But the hardest question was still open. Using measurements from the dry falls, investigators built a working model at 1/50th scale. It reproduced the cliff, the river channel, the talus, the turbulence, even the mist and lighting. Individual model rocks could be removed so experts could compare different versions of Niagara before changing the real one. They studied everything from leaving the talus untouched to clearing nearly all of it. They considered cranes, a cableway stretched across the gorge, and a rock crusher with a conveyor. Depending on how much was removed, the work was estimated at $1 to $15 million and could take 1 or 2 construction seasons. Technically, the rocks could be moved. Visually, some versions produced a higher, cleaner waterfall. But the operation would be irreversible. It would speed erosion, erase the winter ice formations that built across the boulders, and replace a changing landscape with a shape selected by engineers. The investigation had begun with a simple-looking complaint: fallen rocks were spoiling the view. It ended with 4 competing questions. What was safest? What looked best? What could be afforded? And how much human control could Niagara survive while remaining natural? In 1975, the International Joint Commission gave its answer. Do not remove the talus. Do not artificially stabilize the American Falls. Do not undertake major construction simply to preserve a preferred appearance. Improve public safety where necessary, continue watching the rock, and allow the geological process to continue. The answer was not an engineering failure. It was engineering restraint. Today, the immense rock pile is still visible at the base of the American Falls. It is not evidence that crews forgot to finish the job. It is the change both countries decided nature was allowed to keep. In 1969, America demonstrated that it could silence one of the loudest places on the continent. The more important achievement was deciding when to let Niagara speak for itself again.